All right, everybody, hello and welcome back. Today what we're going to do is we are going to work on switching quadratic forms. So essentially what this is going to do is this is just going to require us to use a lot of our algebra toolboxes to manipulate these equations to transition from one equation to the other, one form of a quadratic to the other. Now, this is important because different equations give you different benefits, right? So depending on what we're looking for or what we need, we might want to switch forms, or depending on what we're doing. So our first example here is we're going to go from intercept to standard. Now, you can tell that we are in intercept form here because we have two sets of parentheses with binomials in between. Now, we also have an a value in front, and that a value is negative. So that complicates this process a little bit, but again, I included it for this problem on purpose so we could see the worst case scenario, the most challenging problem that this might be like for us. Now, what we're going to do is we are going to FOIL this out. It's essentially the distributive property. So first we multiply the first value in each binomial. Then we have the outer values. That's going to be x and negative 2. Inner would be 1 and x. And then last we have 1 and negative 2. All we have to do there is simplify, so we end up with y equals, again, that negative 2 is just kind of hanging out in front for now. X squared minus 2x plus 1x minus 2. Y equals negative 2 times x squared minus 1x minus 2. And then my last step is going to be to distribute in that negative 2. We get y equals negative 2x squared plus 2x plus 4. And this is equivalent to our original quadratic, but we are now in standard form. So there are a couple different approaches you could have done here. You could have distributed in this a value in the beginning to one of our binomials and then FOILed out from there. Now, what people tend to do is I often see students distribute this to all values, but that's not how it works. You are then essentially distributing twice, which is not what we want. So I find it's easiest to FOIL out our two binomials and then deal with the a value at the end. All right, so all of the intercept to standard form problems are going to look just like this, except we might not have an a value in front, or it might be 1, so that means we don't have to do this last step of distributing. Essentially, to go from intercept to standard, we are FOILing. Now, next what we're going to do is we're going to go from vertex to standard. It's actually a pretty similar process. Now, we are in vertex form here, which we could see because we have a binomial squared and then a number at the end. So if we think about what an exponent of 2 means, it essentially tells us that there are 2 of these binomials. Once we do this, it's very similar to what we're doing above here. So we are going to first FOIL out our binomials. That 1/2 just gets to hang out in front, and that 1 does at the end. So we'll do first, outer, inner, last. And again, we got that minus 1 at the end. So let's simplify a little bit. We get y equals negative 1/2 times x squared plus 8x plus 16 minus 1. So I'm going to distribute in that negative 1/2 to get y equals negative 1/2 x squared minus 4x minus 8. And then we still have minus 1, which we no longer need our parentheses for. And my last step will just be to simplify by combining some like terms. This is my quadratic that is now in standard form. So again, it is equivalent to what we had in the beginning. So all of our vertex to standard form problems are going to be the same. Again, you might not have an a value in front that's not 1. So you might not have to do the distribution at the end, but again, this is worst case scenario. This is as challenging as a problem like this should get. Now, our next couple examples are going to be going from standard into our different forms. To go from standard to intercept form, we should know that we are going to need to have two sets of parentheses. Now, essentially what we're doing is the reverse of what we did in the beginning. So in the beginning, we FOILed to expand our binomials. Now we want to factor to go from the expanded version to broken down parts. So if we think about it, what ended up happening is in our first step, when I multiplied this first value in the binomial and this first value in the binomial, I got my x squared. So what that tells us here is this value and this value should also multiply to x squared. Now, because these are going to be binomials each, we are going to have x and x. And now what I really need is I need two numbers that are going to multiply to positive 10 and then add to negative 7. So if we struggle to do this, what I would do is first consider values that multiply to 10. So if we do 1 and 10, for example, well, there's no way that those are going to add to negative 7, so that doesn't work. My only other option is 2 and 5. Now that could add to negative 7 if they're both negative, and that checks out because they would both multiply to a positive 10. So I have minus 2 and minus 5. This is my quadratic function in intercept form. All right, so we call this diamond math over here on the side. Some people like to use the box method here. Either one is totally okay with me. It is just going to be up to you. Now, most of our problems to go from standard to intercept form are going to look just like this one. However, there might be a small difference. And now the difference here is our a value is not 2. For now in this unit, when that's the case, that tells you that each one of these coefficients should have something in common. So what we can do is we can divide the 2 to the front. And so if I divide everything by 2, I'll get x squared plus 3x. I guess I don't need that parenthesis. Plus 2. And now I've got that a value in front, which is 2. But now I can factor my quadratic trinomial here. That again has an a value of 1. So I'm going to start with x and x. And now I need two numbers that will multiply to positive 2. And then add to positive 3. Well, the only way that works is because we have two factors that multiply to 2, and it's going to be 2 and 1. So we have positive 2 and positive 1 as our two values. And here is our factored form, our intercept form. Okay, so these problems are actually really similar. They're really only one step apart. And we recognize that when our a value is not 1, we can divide it to the front, and then we should get a trinomial we can factor more easily. All right, so this doesn't happen as often, at least not for us right now. We'll take a look more at factoring in our next unit. More so than not, they're going to look like this problem here. Now, lastly, what we're going to do is we're going to go from standard to vertex form. Now, there are, again, a couple different ways we could do this. What I choose to do in this unit, just kind of a personal preference, is to find our vertex. Now, we already do that in standard form when we're graphing. So I'm going to first find my axes of symmetry, which will be the opposite of b over 2a. So we get negative 4 over 2 times 1. X is negative 2. So that is the x value of my vertex. I am now going to plug it in to find my y value. And we get negative 12. So we'll get 4 minus 8 minus 8 would be negative 12. So here is my vertex. If I know what vertex form looks like, I can just plug in my h and my k values. So I'll end up with y equals x minus a negative 2 turns to a plus 2 squared minus 12. And so one thing I also want to point out here is I still have this a value, But if I look in front in standard form, my a value is 1. So I could put a 1 here, or I can just leave it out because those are going to be essentially the same thing. Well, they'll be exactly the same thing. And this is my new quadratic from standard to vertex form. Now, this isn't always a preferred method. Some people prefer to use what we call completing the square, which is what we're going to do here. Again, I'm okay with you doing either one. That is absolutely going to be up to you. Now, what we're going to want to do is we're going to want to divide our b value by 2, which gives us 2. So what that tells me is I'm going to write this out. I'm going to have x plus 2, since this is a plus. And I am going to give myself a little bit more room first. And I'm going to square it. So we're kind of halfway there now. It looks like we are getting on the right track. Now, we don't always need to show this work, but I like to do it so so we can all see where my values are coming from. Now, I made this into a square because I want it to be in vertex form, which has a binomial squared. But if I were to expand that back out, first, outer, inner, last, I get x squared plus 4x plus 4. Now, this work is not necessary. You do not need to do this. However, let's look at the important part. When I expanded this binomial out, I ended up with this, which is almost the same as what we had in the beginning. The difference here is my c value originally is -8, and here it's 4. So that means that right now these two things are not equal. So what I will have to do is I will have to go from +4 to -8, which we do by subtracting 12. This will be my quadratic in vertex form. So similarly, again, that a value is 1, so I know that this value is going to be 1. And if you notice, we end up with the exact same thing no matter how we choose to do this. That's why if you want to complete the square, that is absolutely fine. If you want to find the vertex like we do when we're graphing, so you're relating it to other concepts from this unit, that is totally fine with me as well. All right, as always, thank you for listening. If you have any questions or concerns, please feel free to reach out.